Today is 1:15, so we can start now. The first talk is from Dr. Nancy Chen from Institute for Infocom Research, A-Star Institute, Singapore. And the title is Summarizing Conversations from Meetings to Social Media Chats.
Hello, can everyone hear me? Okay, good afternoon, everyone. I'm Nancy Chen. Today, I'm very happy to have this opportunity to share this survey talk with you on summarizing conversations from meetings to social media chats. Is my voice a little echoey? It's okay? So human-to-human conversations is a very unique human phenomenon where we use this to pass down knowledge, to convey emotions, to collaborate with one another. And it's a very natural means of how humans work with each other. And so it's a very dynamic process of information exchange between multiple parties. And this process unfolds and evolves over time. But how do we distill the unstructured information in these conversations and use it in downstream tasks is still very non-trivial. And so we'll be discussing some of these aspects today and look at it from a more historical perspective and see how we'll be moving forward. So first, some terminology. So in our field of speech and spoken language processing, we represent it with this yellow circle. It intersects with the field of summarization, which is a subtask in natural language generation and natural language processing. So the intersection can be called speech summarization. So if we add in dialogue to the mix, then we have these three circles. And then the middle is the part that we call spoken conversation summarization. Together with this other part, that's in purple stripes, chat summarization, it forms conversation summarization. So it's a very interdisciplinary field that intersects with a lot of different disciplines. And we'll be looking into the similarities between chat and spoken conversations and how the field has evolved. So speech has played a very central role in this, and we will take a historical perspective. So back in 2001, ICSI, International Computer Science Institute at Berkeley, started ICSI Meeting Project. 2 years later, they released the ICSI Meeting Corpus along with their ICAS paper. At the same time, DARPA was funding 2 summarization projects. So one started actually in 2000 to 2005, another in 2005, and there were NLP and speech researchers on it. And so they started applying a lot of the techniques you use in text summarization to speech and realized that there are a lot of different unique challenges that's not easy to resolve, and especially in the meeting context. At the same time, the European Commission also funded related projects to meetings. And so AMI, or the AMI Meeting Corpus, is one example that was released in 2006. It's a multimodal, multi-party meeting corpus. It has a lot of annotations. It has both extractive and abstractive summaries produced by humans with different dialogue acts, and it also uses microphone arrays to capture the speech signal. So it's a really rich data set. So these kind of set the ground of a lot of work that went forward. And in this era, a lot of the work in speech summarization focused on extractive approaches. So that means that given the speech or spoken document or the meetings corpus, you try to extract out important key phrases or keywords directly from the source. And during this era, a lot of the technical approaches were influenced by fields like information retrieval, where people use, like in Google, people use PageRank to rank the retrieved results. Also, statistical machine learning also played a role in how people formulated how you thought you would do this kind of extractive or retrieval task. So in 2011, we showed that speech recognition can be applied to, well, deep learning can be applied to speech recognition. And so this started changing how people thought about what kind of technical approaches you can use. The deep learning wave hit NLP a little later. 3 years later, neuro-machine translation was proposed, and this paper here is quite iconic and was accepted clear in 2015. So usually in NLP, one of the first tasks that people apply new methods to is machine translation, which is one of the widely used generation tasks. So other generation tasks include summarization and dialogue response generation. So a couple years later, Google announced that they're using neural machine translation for their Google translation services. So this is another milestone where in the production side services, neural methods were also adopted. And then in 2017, open source tools like OpenNLP were available to researchers. So then you could use these to start training your own end-to-end sequence-to-sequence models for generation tasks. And so this was also another milestone that made it easier for more people to experiment how you can use these neural approaches for these different tasks. And then in 2 years, and then actually, yeah, so then the same year, maybe half a year later at ACL, a paper on pointer generator networks came out. And so this is an example where you can use these neural methods to do abstracted document summarization. So here they showed it on news summarization. So in the past, you could maybe just use the pointer network to copy things from the source material, but now together with the generator network, you can also combine it with new novel words that never appeared in the source document to summarize what you saw in the source. So this was a breakthrough in the sense that it's the first time that we can use a more computational approach to do abstractive summarization. In the past, if you want to do something computational, you would go more on the extractive end because you will need to rely on linguistic templates to construct the output text. And so that was a little more less computational. So for people that have a more computational bent, then they would lean to the extractive side. But now things have changed. And then in 2019, pointer generator networks were adopted for spoken conversations to summarize them. And then the same year, a little later, also a couple months later, after this paper, Samsung released the Samsung corpus. And this corpus has more than 14,000 message chats along with human-produced abstractive summaries. So this was important because then we had sufficient data to do supervised learning of these abstractive neural summarization models. And late in 2019, BERT came out. So this was another hallmark where people start changing how they thought about applying representation, because here we have this pre-trained model that has deep bidirectional transformers to help you represent language data. And so people started adopting this. A lot of them is for maybe more classification tasks. And then a year later, BART came out. So BART is more suitable for natural language generation tasks. And so now, so for this past several years, maybe starting 2017, 2018, 2019, then a lot more work has been in abstractive conversation summarization using all the tools and philosophies, empirical findings from what I just described. And so now here we are at 2022 INTERSPEECH. And so we'll be taking a look at how papers in conversation summarization are like in INTERSPEECH 2022. So the previous slide was a little cluttered. So here is a extraction of it to kind of show the more technical trends, starting from in speech summarization. A lot of it in the beginning was more monologues. So this could be broadcast news or lectures where it's mainly one person talking, along with the meetings data. And then it started moving to beyond meetings. You might have different consultations that are in the form of dialogues and meetings, and then also text messaging and online forums. And so you see the shift of how people use different tasks and different approaches to solve these problems with different data sets and applications. And so here I wanted to bring your attention to the different types of conversations we've seen, both the spoken kind and the messaging kind. So the main difference here is that for spoken conversations, usually it's synchronous. It happens, the people that are participating in the conversation are at the same place at the same time. So right after I speak, I immediately see a response from others quickly in real time. So if it's in a messaging context where you're typing your messages, so you may not participate in real time, so your messages or replies might come in later. So in that sense, it's more asynchronous. So this is the main difference between these two forms of conversations, but they share a lot of similarities. So here, assuming that your goal is to get the main semantic message from these conversations, then a lot of the other things that are happening could be viewed as noise sources. So I summarized it in a couple different types. So the first type is these conversations are more spontaneous. So a large part of NLP deals with documents. When you see the document, it's already a polished product of what the writer wants to say. So the writer has already went through revisions of what she or he wanted to convey, and you see this final thing. But if we're doing an information exchange, everything's in the process. So while I'm talking to you, I gradually understand you more, and so we might revise how we both think about things. So you don't get to see the very polished end. The very polished end might be the summaries that I generate afterwards. But in the process, you'll have a lot of natural disfluencies. So one of the disfluencies could be that when I'm talking, I have different hesitations and pauses. It could be mispronunciation. And then on the messaging side, it's noisy user-generated text. So you could have misspellings. You could have fragmented utterances that are not necessarily grammatically correct. And because we have a limited attention span, so when I'm talking to you, I cannot use a very, very long sentence. If I do, a lot of it will be lost in translation. So you would easily make it into shorter utterances. And if I feel like you're not getting the message, I might repeat in a different way. So it's a little more verbose. So this is one aspect of it. The other type of noise comes from the misalignment between when we speak and when we think. So sometimes I might think aloud and realize, oh, later I need to go to this meeting. So when I do that, when it's a human to human conversation, you get it that right now I'm not talking to you, you know I'm talking to myself. So you already have this mental switch. So you can understand what I'm saying better. But for computers, this may not be the case. There are other cases where you might type or speak too fast before you actually carry out your full thinking process. So when it's spoken, then it's hard to retrieve the message. If you're typing, then nowadays in some apps you can delete the message. But these are some of the misalignments we have with speaking and thinking. And then sometimes there are false starts, which I often did in this talk, where I realized, oh, I might need to start the sentence in a different way. And sometimes you could create different types of self-contradictions. It could be cautious or unconscious. So it could be that while talking, I realized I recalled my memory wrongly about when that paper came out. So I correct it implicitly or explicitly. It could be that I understand you better, so I change my frame of talking. So these are different types of noise that comes from this kind of misalignment between speaking and thinking. The other type of noise comes from that there are multiple people joining in this interaction and conversation. So you might have people talking at the same time. It could be intentional or unintentional. You have speaker interruptions. It could be you just cannot wait for the other person to finish speaking. And so these cause different types of overlaps, and it can happen in messaging too. The other part is that when we're having these conversations, it's a social interaction. So we tend to do different types of back channeling and reconfirmation. So some of it is through verbal means. So I might say yes. And so I may not necessarily agree with what you're saying, but when I say this, it shows that I acknowledge I heard you. I'm here listening, and I want you to know that I'm here. So when you're messaging, you could use different emojis to represent this as well. It could be likes, it could be smiley face. So these are more of the social aspects of it, and it may not necessarily be super essential if your main message, if you mainly want to summarize the semantic message. So you could see a lot of these parallels and similarities between two types of conversations. And so the technical approaches to resolve these noise sources could be similar. And so that's why actually, if you come from a speech background and you need to work on this, you have a huge advantage because you're very used to a lot of this messiness and noise that you need to deal with when you're working on spoken data. And so it gives you a different perspective of how you can handle this kind of noise. So here are 4 papers that are on conversation summarization at INTERSPEECH 2022. So I listed when they will be presented so that if you're interested, you could get a more detailed view and ask questions about a lot of the technical details. And then I'll be going through each of them to give you the highlights of each paper so you get a sense of what's happening. But before that, I would like to show that these are some of the general trends in neural language generation, and we can see parallels in INTERSPEECH 2022 as well. So neural language generation basically means that you use neural approaches to solve language generation tasks. And language generation tasks could be machine translation, summarization, or dialogue response generation, any kind of task where the output is human understandable text. The input could be speech, could be text, could be audio, could be multimodal. So, so some of that I already alluded to. So one of the trends is that there's a rise in abstractive conversation summarization. So we see 3 out of 4 papers work on the abstractive summarization task. The other trend you see is the declining influence on methods from information retrieval and statistical machine learning. And then people are leveraging a lot on these pre-trained representations. It could be speech, it could be text, and then definitely using a neural framework in a sequence-to-sequence learning framework. And another thing that I didn't previously mention is, but it's very important, is that in neural language generation, one common issue we face is that the output text that you generate through these neural networks could be too creative, where it's actually factually inconsistent with the source material. So this factual inconsistency between the source and the output is called hallucination. And so it'll be more ideal that people evaluate this aspect of the generation results as well to know that how far away are you from producing something really usable where at least it's factually consistent, you're not making up non-truth stuff. And so among the 4 papers here, 2 of them did factual consistency analysis and evaluation. Okay, so I'll now go into each of the papers. Okay, so the first one, I'm also a co-author on it. It's on dynamic sliding window modeling for abstractive meeting summarization. So the paper here, the idea is that a lot of these meetings are pretty long, like in AMI or AMI, it's like 1 hour. So it's pretty long. So one way to do this is to divide and conquer. You can split this big meeting summarization task into smaller summarization tasks. And it's not so hard in meetings because you'll usually have meeting agenda items. So each one of them can correspond to a subtopic. And then so you can use a dynamic sliding window to decompose the whole meeting into more contextualized semantic chunks so that when you're modeling, you don't accidentally lose out on certain information. And this also elegantly bypasses the token limitation of large language models. So people like to use these large language models, but sometimes it's not easy to use it because they have certain limitations of how much data you can put into the input. So if you truncate it arbitrarily, then you might be losing out on information. But if you have a more elegant way to include all the information in a more contextualized manner, then you don't need to be afraid that you're losing out on certain information. So this is one. The other one is on extractive speech summarization for an untranscribed meetings. And so here is one example where when you're working on speech, there's this advantage where you could, you may not always need to get the transcribed text to summarize it. You can use other means to extract out the important key phrases. And so here, the difference here than past work is this paper used deep speech representations from Wave to Vec 2.0 to do the latent semantic analysis to infer where the topic words and content words. And so the idea here is that then you don't need speech recognition before and you don't need speech synthesis later, so you can just directly extract and display the audio of important segments. Okay. And then this third paper is on negative guided abstractive dialogue summarization. So the idea here is inspired by contrastive learning, where while you're maximizing the salient information in your source document or source dialogue, you want to minimize redundancy. And so here you can define how you want to define the negative summary examples. So here they use a self-supervised way with the Rouge metric to get redundancy so that you can have a larger contrast when you're doing this optimization problem. And so in spirit, it's similar to MMR, which is maximal marginal relevance, that was used more than 2 decades ago. It's pretty popular in document summarization. But in MMR, they maximize the salience instead of in MMR, they maximize diversity, and in this paper, they maximize salience. And another difference is the problem set up here is using transformer as a base backbone and in a sequence-to-sequence learning manner. And so this paper used the Samsung corpus, which was on social media messaging. And then this fourth paper is a clinical example. So here, what they first did was they did utterance selection. So they select utterances that are most clinically relevant, and they changed it to a classification class of span labels, where the span labels were defined in the medical context. And the utterance selection problem was treated as a sequence tagging problem. And then they input the selected utterances into the summarization framework, where they use BART as the backbone. And so they also had this problem of the token limitation, and here they use certain thresholding and slicing to make the input more concise. And so this was done on a private clinical consultation data. So here I want to do some discussions and have some brief remarks. So, so what we view as information and what we view as noise actually largely depends on the use case. And in summarization, it's often under-specified in the academic context. Depending on your application, you might need to change things around. So for example, just now, my default was that we're gonna distill out the semantic messages, the main message. But sometimes what you want to summarize could be something different. It could be that you want to summarize the social interactions instead. Then in this case, back channeling information is no longer considered noise. It might be more essential to your final topic. So this is one thing that people might need to have in mind, because you'll be facing different types of applications that need summarization and need to refocus your task depending on the scenario. Another example is you might need domain knowledge to fill in to help specify these summarization tasks. So just now we showed an example in the healthcare. And another thing is, if you really want to deploy the model, sometimes it's easier to use an extractive or classification approach, where you can bypass the hallucination side effects of neurogeneration. The third one is a more fundamental research problem, where traditionally we know it has been a longstanding problem that we are not very good at processing long text or dialogue. And this continues to be an issue, even though we have made a lot of advancements in the so-called pre-trained language models. And so this is still an issue that's ongoing, and probably need to look into it a little more deeply at the fundamentals. So here, going forward, I'd like to point out some things that I think could be interesting to look into. So the first one is factual inconsistency. So we really need to resolve it before you can start deploying these abstractive summarization models. And so here, in the very minimum, we need to do more error analysis and interpretation to understand where are the fallacies of these models. And then there will be more domain-specific applications arising. So some of them are in the startup space and industry that you may not always see a lot of papers, but there is a need out there. There's another type of need where we all see now, and when we attend conferences, there's more need for hybrid meetings. And then a lot of professional services might start providing teleconference options. And so along with the increased usage of social media, we'll definitely need to consider multimodal modeling approaches more. So this could be speech and text, and video and images could also come into the mix as well. So yeah, so this is what I'd like to share with all of you. Please let me know if you have any questions or comments. Thank you. Can we change?
Thank you for your presentation. When you do speech summarization, do you see differences between speakers? Are some speakers more easy to summarize than other ones? Because as a listener, I have this feeling. Sometimes after a presentation, I think to myself, okay, what were the most important things mentioned? And for some speakers, this can depend on the voice, the way of speaking, the utterances. But do you see difference between?
Yes, yes, yeah. You brought up a big point that I didn't mention explicitly in the talk. Yeah, so there actually have been approaches where people do explicitly put speaker information as one of the factors to consider. So there are different reasons for that. So some of it is, as you said, some people are better at summarizing information and is more articulate, and also acoustically the information is conveyed in a way that's easier to be absorbed. And another aspect is depending on the conversation. Some of them, like in meetings, you might usually have someone that is moderating the meeting, someone that's running the meeting, and by definition, that person might need to do the do the summary more. You summarize what happened previously, summarize what you discussed today, and what are the follow-up actions. So if you have access to be able to model with who is that speaker that will be doing that, then it definitely helps a lot. So these are actually people have integrated these type of approaches into the models, and that's definitely what I see anecdotally, qualitatively as well. Yeah, thank you. I think I saw some.
I'm curious if you have any thoughts or if you know of any data sets specific to video conferencing.
Sorry, I couldn't hear your question. Your question is.
Do you have thoughts on video conferencing where conversations are a little different because people are sometimes on mute, so you don't get back channels or things like that, where they are not, there's latency, things like that. Have you explored video conferencing specifically?
Oh, video conferencing. Yeah. So I think actually the back channeling effect happens much more often than we think. So when it's not in a video conferencing setup where it's just human to human, I may not even be aware that it's being recorded. Uh, it happens a lot just because we're very social animals, even especially actually over the telephone. You might really only rely on the acoustic cues to let the other person know you're here. So if it's face to face, you could use your eye contact and other kinds of body language to show that you're listening. So 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 you're saying, so in the video conference data, I haven't looked at it explicitly, but I have colleagues collecting it. So there, anecdotally, we know that sometimes uh, it could be unintentional latency and pauses created by technical difficulties, or just because you're trying to capture the other person's scenario in this very two-dimensional flat screen. So you might be a little slower than usual to respond, and this could cause people thinking, oh, did the person not like me? Did I say something wrong? So there's probably a lot of rich social information there, but I haven't seen as much analysis on it. But it's definitely something that I think might become more prevalent or more needed when we're trying to understand human to human conversations.
Great, thank you.
So I know with data sets like Samsung, you actually have the names of the people who are speaking with each other. Whereas in like a meeting recording, that would more have to be done with speaker ID. I'm imagining if I said, okay, so you'll do that if the action's to be recorded. Has there been much thought as to how much of a role speaker ID would have to play in this sort of summarization?
Yeah, so I guess I think in like the AMI corpus, there's also roles of the speaker that's there. So that kind of helps. So sometimes depending on your role, then you, like if you're the moderator, for example, your information might be more closer to summaries. So yeah, so definitely, I think for the meeting summarization projects, very interdisciplinary. So a lot of the front end processing helps make a big difference. So the speaker identification, the speaker diarization, all helps a lot to help you locate where the different sources of information are coming from. Another aspect that I didn't really put inside is that one difference between documents and documents and conversations is that when we're having a conversation, the message I'm saying is from my perspective. The message you're saying is from your perspective. So as a listener, you keep switching back and forth between these perspectives. And then there are different linguistic phenomena like co-referencing that's happening. So you need to keep understanding, oh, when I say he, who am I referring to? When I say Nancy or the speaker, is that the same person? And so these things definitely help if you know who is making that spoken content available to you. Yeah, so that's really something that even children, they take some time to learn that and understand what the conversations are about. And then this is something that people have not been doing as much when they look at these conversations from a pure document processing perspective. So actually, we applied this information, this co-referencing information into these frameworks and helped improve the state-of-the-art performance. I didn't show this because it wasn't an INTERSPEECH paper, but it won the Best Paper Award at SIGDIAL. So this is definitely something where if you're coming from a speech background, it's very intuitive to you that if the speaker is different, you're going to get different types of information, and it really makes a difference when you want to understand the conversations. So this is a huge advantage of our.
Thank you.
Very interesting talk. So following up, I guess, on what you just started in the previous question, how much of an impact does perspective have on the output of the summarized conversation? Because as you just alluded to, two different people in the same conversation could potentially summarize the conversation differently, right?
Yeah. So that is actually, I didn't show it here because we are supposed to talk about the INTERSPEECH papers. But yeah, but we have other papers that were published in EMNLP where we actually do show that if it's from a different person's perspective, the summary would be different. So there are many different examples. So one example could be in the medical context. So I'm the nurse, I'm calling you, you're the son of a patient. So we're talking about your dad's situation. So as a nurse, when I summarize the conversation, I I am coming from a clinical perspective. I realize he's doing well. I don't need to see him so soon. From the son's perspective, it could be a little different. There are follow-up actions that the caregiver as the son needs to take on. And then there's also a perspective from the patient's perspective, although he's only mentioned in the conversation. So depending on your application task, you would need different summaries. And then if I'm actually an administrator in the hospital, to me, maybe what I really care about is how much of a liability from a business perspective is this patient? How much financial resources do we need to spend on this person? So then you will need to come from an inferring angle of, oh, if he's doing well, that's good, but you're looking from the financial side of things, and then your summary output will be different. If on the other scenario, if the patient is not doing well, then you might need to be alerted that, oh, we might have more financial costs. What should we do to minimize that? So the perspective would be different, and the follow-up actions from these conversations would be different. So one thing to note is that in these conversations or meetings, a very key part is what is the implied action item afterwards. And so that usually links with a summary. And depending on how you want to use the summary information, you might structure it differently. And so in that sense, a lot of the academic work focuses on more of the beginning part, but how you link it to the actual applications, there might be different ways, and you really need to understand the use case scenario well to do a good job.
Thank you.
Hi, thank you for the talk. I was wondering, especially with the ESS sum work, if there's any place for explicit process information and summarization, or are you actively using it, or just relying on the text information based on ASR?
Oh, so in the ESS example, they don't go through ASR. So they just, you can infer what are some of the acoustic units that are maybe more topically important. So traditionally, people would do maybe term frequency, inverse document frequency, TF-IDF, on acoustic units. And then if you have a high score from this, then it might imply that this is a important content word, and then utterances around it might be more important. So basically, that paper is doing something like this, which was one way to do things before deep learning, but they're using a more deep learning representation to do it. Yeah. Does that make sense?
Yeah, it does, but it's not using then prosody in as much as phonetic information. It's not
Um,
using the prosodic information.
Oh, in this case, they are not necessarily, I mean, the prosodic information might be very implied depending on how much is in the speech representations they're using. Yeah, so in the past, people have explicitly used prosodic information in the extractive speech summarization use case because definitely we give out a lot of prosodic cues when we're talking. And this is very, in some sense, sometimes language dependent. So in English, it's not a tonal language. So my pitch contours definitely help shape where I think are the important information where I'm trying to tell you. But if you're like working on a tonal language, then the prosodic structure might be different because at each syllable you have a different tone, and these are the local ones, and you need to capture the global ones, which might interfere or overlap with the local information. So there is a little bit of that uh, could be a little language dependent
Right.
if
Thank you
it's
very much.
prosodic.
Okay, for the sake of time, let's conclude the talk and let's thank to Dr. Chen.
Thank you.
We'll start in 2 minutes.
I wasn't sure.
Okay, let's start the second talk. So the second talk is from Dr. Esther Klabbers from ReadSpeaker, and the title of the presentation is Speech Synthesis in Conversational AI.
Okay, thank you. All right, so I know this is a survey talk, but I figured I'd give a short introduction into my own background as well to show you why I would be someone to be able to talk about this topic. So from 96 to 2000, I was a PhD student at the Institute for Perception Research in Eindhoven in the Netherlands. And in that project, I worked on diphone synthesis and phrase concatenation in the context of the NWO OVIS project, where we built a spoken dialogue system for train travel information. And basically, you can see a spoken dialogue system as a precursor to our current conversational AI space, which is why I'm bringing it up. And after that, I moved to the US, where I worked at the Center for Spoken Language Understanding on diphone synthesis again. And then in 2014, I joined ReadSpeaker. And at ReadSpeaker, we're building state-of-the-art text-to-speech voices for lots of different speakers and languages. And I'm also involved in mentoring and working together with academia. And so one of the projects that I'm involved in that I will talk a little bit about today to mention a few of the papers here at INTERSPEECH is the EU COBRA project, which stands for Conversational Brains. And it's a project, it's a European training project that trains 15 PhD students on this topic. And there are at least 3 PhD students who are either directly or indirectly doing research on text-to-speech in this context. So conversational AI, it's a type of artificial intelligence that enables consumers to interact with computer applications just the way they would with other humans. I'm assuming most people are aware. And current state-of-the-art neural network speech synthesis is really good right now, and it's capable of generating expressive speech that sounds intelligible and natural. But there's still several issues to consider when developing speech synthesis for conversational AI applications. And so in this survey talk, I want to kind of give an overview of some of these considerations pertaining to the training data collection, acoustic model architectures of the synthesis system, and evaluation of the generated speech in the context of conversational AI. So yeah, speech synthesis has been around for decades. Given this conference venue, everybody knows about it. But it's evolved a lot over the last decades. It started with like formant synthesis or articulatory synthesis, and then it moved to diphone synthesis, unit selection, and then HMMs and DNNs, and currently neural nets. And as the computing capabilities increased dramatically, the technology evolved. And so the early systems were based on very small data sets from like one single speaker, and researchers would extract a lot of linguistic and acoustic information from those data sets and build like rule-based systems. And nowadays we just collect a lot of data from professional voice talents, and we train neural network synthesis. And as the quality improved with this evolution, and the intelligibility could be almost perfect and the naturalness can be really good, so did the demand for more challenging use cases. I'll give a brief overview for those of you who are not in the text-to-speech field. So the current neural network-based synthesizers typically consist of 3 different modules. The first module is the linguistic front end, which translates the text input that you want to synthesize into linguistic features. And it uses mechanisms such as text normalization, abbreviation expansion, number-to-word conversion, homograph disambiguation, detection of English words in non-English texts, and pronunciation prediction. And it has been shown that by using linguistic features such as phoneme labels and word boundary labels and so on instead of the raw text, you get better quality speech synthesis. The second module is often called the acoustic model, and it's a neural network which learns a mapping between these linguistic features and the acoustic features that belong to the same message. So yeah, whenever you record a voice, you collect the acoustic data and you transcribe the text of it. And so that's how you get these pairs of linguistic input and acoustic output. And you train a neural network with that, yeah, to learn the mapping. And typically the acoustic parameters are Mel spectrogram features, and sometimes also pitch or F0 and the energy. And then finally, there's a neural vocoder, which is also a neural network, which learns the mapping between these acoustic parameters and the audio signal. Now, as I mentioned in the beginning, when I first was doing my PhD, I was working on a spoken dialogue system. And it's kind of a subset of conversational AI. They were very limited domain applications because back then the technology didn't really support spontaneous dialogues yet. And at that time we used diphone synthesis and later unit selection synthesis. And so one of the people who was really instrumental in introducing dialogue information in the speech synthesizer was Anne Sordell, who used to work at AT&T. And I would say she really was a trailblazer in that area. And so one of the papers that she co-wrote was on annotating dialogue speech acts in speech synthesis and showing that the output speech was better quality and more appropriate for the application. Now, currently, yeah, conversational AI is everywhere, I would say. We have text-based conversational agents like chatbots. Whenever you have a flight or anything, you have a complaint somewhere, it's like, would you like to connect to our text service? And you automatically get a chatbot on the line and they will try to answer your questions, maybe not always correctly. Speech-based conversational agents like voice bots, personal assistants are everywhere on people's phones and devices in your home, route guidance, and so on. And also multimodal agents like avatars or robots are very common. And yeah, as we can see at INTERSPEECH and all around us, there are many interested parties in this field working on speech synthesis in the conversational AI setting. This is not an exhaustive list, so just mentioning some of the big players. And there's also in academia, there's also an interest in this, for instance, at KTH in Sweden, and as I mentioned before, the European COBRA Consortium. One thing when talking with people who work in the conversational design space is interesting to figure out what what they want from GTS voices, how we can create voices that are suitable for this kind of application. And so, yeah, the first question is, how do you create a voice that speaks in a conversational speaking style, and what does that even mean? What is a conversational speaking style, and what kind of conversations are you planning to generate? Are they spontaneous conversations, or are they kind of task oriented, like you're going to the movies and you want to buy tickets on or something like that? So there's a lot of questions there, and that has repercussions for what kind of voice you're developing and how you're collecting the data. They want to have a wide variety of voices, and creating a voice takes a lot of time and effort. They sometimes want branded voices, so a voice that really matches the brand of the company. They want to be able to express different emotions or intents and synthesize back channels such as aha, that sort of thing. Um, um, generate context-aware prosody and be able to control the prosody, including which words are being emphasized. So typically when you build a text-to-speech voice, you collect a text corpus with text from various sources, and then you convert it to the pronunciations based on some lexicon, grapheme to phoneme predictions, and homograph disambiguation rules. And the manuscript should contain a wide variety of phonetic and prosodic contexts so that when you're synthesizing new material, you have a good coverage of different things that you can find. And then it's recorded by a professional voice talent in a studio. And sometimes, but not always, these recordings are segmented so that you know where all the sounds are occurring in the audio signal. And they're also manually checked to make sure the voice talent said, what was in the script. There's no mismatch there. And typically, the material that's collected is consisting of isolated sentences that are just read one by one. And the text material can come from the web or from novels. It's not really suitable for a conversational TTS. And one thing that we found also is that there's a very skewed distribution of utterances where, most text material, you don't really have a lot of questions. Whereas, if you're having a conversation with someone or task-oriented dialogue, you're going to have much more need for questions, and you want to make sure that in your synthesis, you can also synthesize the appropriate question intonation, which means that you have to have adequate coverage of those kind of phenomena. And also, utterances tend to be longer in this kind of text material than in most dialogue situations. So there's 3 types of methods of data collection for conversational AI. There's ReadSpeech, which is similar to what I just mentioned for any TTS voice. There's performed dialogue speech, and there's spontaneous speech. And I just want to give a limited overview of a few recent papers that have collected data for conversational speech. So the first one is from INTERSPEECH last year, 2021, called ReadSpeaker, a corpus for conversational text-to-speech synthesis. And the material for that corpus came from 3 different sources. The Ryan chatbot, Google Taskmaster 2 dialogues, and LibreTTS. And what's kind of interesting, if you look at the bar plot there, it lists the audio length per recording. And so the ReadSpeech one is on the left. You can see that it tends to be a lot shorter than, for instance, LibreTTS or LibreSpeech. So that confirms that for dialogue material, the length tends to be a lot shorter of all the utterances. In the performed dialogue setting, there's a paper from Microsoft, from Guo et al., called Conversational End-to-End TTS for Voice Agents. And there they talk about 3 different ways to collect the data. It's kind of similar to what I just mentioned. So on the left, there's the ReadSpeech scenario. In the middle, there's the free talk or spontaneous scenario. And on the right is the performing talk scenario. And the problem with the free talk one is that you can have overlap between speakers. There's going to be a lot more hesitations or restarts and that sort of thing. So it's a lot harder to clean up the data to train a model. Whereas if you do the performing talk, you can kind of control it better, but you still have a more realistic dialogue that people are acting out. And so they built a model with this material where they first trained an acoustic model with ReadSpeech and then fine-tuned it with a smaller set of performing dialogue from the agent's side. And then finally, for spontaneous conversations, at KTH, they've been working on that. So Eva Zekeli et al. Have worked on spontaneous conversational speech synthesis from found data, and they use data from a podcast with multiple speakers. And so, yeah, as I mentioned already, there can be overlapping speech and disfluency. So you have to clean it up and figure out what kind of data is suitable to train your model with. Okay. Then the second thing on my list was talking about acoustic model architectures. So in addition to having specific data that deals with dialogues, you can also add things to the acoustic model to infuse it with some more information about the context or about the dialogue. So again, the Microsoft paper from Guo et al. Talks about adding 2 different encoders to their acoustic model. One is an auxiliary encoder that uses BERT embeddings to provide latent semantic and syntactic information. And one is a conversational context encoder, which provides the chat history in the form of sentence level BERT embeddings over a window of several previous utterances. And they did a comparison test between these different models, and they found that the model that has both the auxiliary encoder and the conversational context encoder was preferred by the listeners over the other 2 models. And so that shows that, yeah, it's a good idea to include that kind of information and get a more appropriate dialogue synthesis generated. Then there's also from IBM, Shechtman and Ben David, there's a paper that was at speech synthesis workshop last year. And the interesting part there, it's about acquiring conversational speaking style, is that they used a hierarchical prosodic control model next to their sequence-to-sequence model, and that they trained that model not on the same speech that they used for the synthesizer, but they trained it on switchboard data. And the quality of the switchboard data is not good enough for synthesis, but it did provide them with some prosody information, and it's dialogue data. And let's see, all right, I'm gonna skip ahead here a little bit. And then finally, talking about evaluation, I think this is really important because, yeah, in the past, we've always talked about intelligibility and naturalness, and it's become kind of this game where, oh, the naturalness improved by 1/100% or whatever. But it's really hard to measure those things, and it's not necessarily useful when you're talking about specific applications like conversational AI applications. And so in 2019 at the speech synthesis workshop, there was a paper by Petra Wagner and a lot of other people in our field about speech synthesis evaluation. And it really suggested that we need to start widening our view and looking at other ways to evaluate the quality of our synthesis. And one of the things they mention is contextual appropriateness. So really defining subjective listening tests that have like a practical application where you can ask, yeah, if you have like question answering or something, how coherent does this sound, or how appropriate is this follow-up message to what you just heard? And also you can work on assessing like what does the listener need from the synthesizer in this application, and what are their preferences and expectations. Then last year at the speech synthesis workshop, there was also a paper by Johanna O'Mahony et al. And Johanna is also one of the PhD students in the COBRA project. And this paper was about what factors lead to differences in the mean opinion scores when you're evaluating synthetic speech. And so one thing they tested was if you don't just ask how natural the stimulus is, but if you ask how appropriate the stimulus is, then there were lower ratings on the MOS scale when stimuli were rated in isolation than when they were presented in context. Yeah, I can yeah, read the paper. And then finally, what was also an interesting paper last year at INTERSPEECH was about evaluating prosody transfer. And so prosody transfer is also something that is used a lot in generating expressive speech because we don't necessarily have the means to record so much data to create all the speech with different emotions and different conversational settings. So how can you use information from other databases to transfer the prosody onto your data set? And this paper is about how do you evaluate this type of process. And yeah, the interesting thing is like if they were interested in the emotion instead of just rating the quality, or yeah, you can ask, okay, which emotion is most represented in the utterance, or when you are asking about topical emphasis, like which word is more strongly emphasized, or which question is best answered by this sample. And I think it really helps to get some more detailed information from the speech instead of just getting, yeah, this sounds good, or I'm okay with how this sounds. Really trying to ask yourself how we can improve the appropriateness of the audio and make it fit the application. So finally, what can we find at this INTERSPEECH? So I'm sure there's a lot more than what I'm showing here. There are lots of papers in our field that are dealing with emotional speech synthesis, or transfer, or data augmentation, that sort of thing. But specifically with conversational text-to-speech, these are the 4 papers that I can recommend. So the first one is by Julia Comini et al. And it's tomorrow, a poster session. And it's called Low Data, No Problem, Low Resource, Language Agnostic Conversational Text-to-Speech via F0 conditioned data augmentation. And it's from the Amazon Alexa team. Then also tomorrow is Adaisy Adigwe and myself in the context of the COBRA project, strategies for developing a conversational speech data set for text-to-speech synthesis. And on Wednesday, Johanna O'Mahony et al. Talk about combining conversational speech with ReadSpeech to improve the prosody in text-to-speech synthesis. And on Thursday, a virtual poster by Raul Fernandez et al. From IBM, talking about transplantation of conversational speaking style with interjections and sequence-to-sequence speech synthesis. So to sum up, I think speech synthesis in conversational AI presents really interesting case studies for the technology. And by working together with conversational UX designers and using knowledge about linguistics and acoustics, we can create better data sets to train these synthetic voices. And we can incorporate context into the acoustic model to generate appropriate and coherent speech. And we can look at evaluation methods with more detailed setups and analyses to understand whether some of our design choices have the desired effect. And that's it for me. Are there any questions?
Is there questions?
Thank you for your presentation. In the beginning, you had a wish list of people, and then, but people have very different preferences for voices. And this differs a lot between. So, how can you cope with it? For instance, in selecting professional speaker, how do you do this, given all these different preferences that people have?
It's not easy. I mean, there's always a trade-off between what will make a good synthesis voice and what a customer prefers. And sometimes they're like, oh, we really want to use this speaker. And then you're like, okay, doing some test recording. And you're like, yeah, that's good, but they're not necessarily good will make a good synthesis voice. So
Do you notice? Can you test this in advance whether one professional speaker is more suitable for speech synthesis than another one?
we do make some test recordings usually, and then we kind of get a feel like how accurate are they in their pronunciations, and are they easily coachable. Like sometimes that really speeds things up if someone is very quick to take up your directions and stuff like
Not
that.
specific aspects of their voice.
Yeah, I mean, mostly it's just about articulation, and yeah, we do some informal testing, like how do we think it sounds, and we have like a ranking. If we have multiple voices, we'll say, okay, everybody on our team fill out this spreadsheet and say which voice you prefer. But that doesn't necessarily mean that our preference gets.
And similar for found data, can you then also select which data you should use for speech synthesis? For instance, more clearly articulated data, or
Um, yeah, I'm not sure if they've really looked at that yet, but yeah, you could do something like that. I mean, with using ASR, you could transcribe the data and then figure out like if you have a not a very good match, or if you find really long um, segment labels and you look at the data and it's totally mismatched, you could say, oh, that's not a very good speaker, or yeah.
yeah, you could do acoustic analysis and look at, for instance, the vowel space.
Right.
Yeah. Okay.
Yeah. Thanks.
There's been these moves towards neural systems which are hard to really understand what they're doing internally. In the old days, I guess, we had a more causal model. We kind of did more what I'd represent as science,
Uh-huh.
in the sense of understanding why these things happen. We got understanding of human communication and production.
Right.
How do we get that out of the current state of the art and the kind of models that we're building now? How do we gain better understanding of human conversation from the approaches that we're using now?
That's a really good question. I think what's really important is to kind of look at it more as a data-centric AI problem, and really focus on the data and how to collect the best data and analyze like different scenarios before building a voice, and not just saying, okay, we have this huge database and now we're just going to train a model and it'll do whatever it does. But if you're really deliberate in saying, okay, we want conversational data, and we want to have a lot of questions in there, and we want to see what kind of variability we find in that data, and how do we best model it then in our acoustic model. I think that's really important to kind of have that, um, yeah, that cycle where you look at the data, and you collect the data deliberately, and then you train your model, and then you say, okay, we really are missing something there, so we kind of go back, and next time we'll we'll do even a better job, I would say.
In fact, you didn't mention so much the interlocutor. I think what is really, in my opinion, a key feature is this problem of alignment effect on mutual adaptation and so on. So I don't see, I asked this question to Thomas Drugman, and the answer was very surprising for me. They don't want to have systems that adapt and signal to the listener that you are speaking not a very good English and so on. So they don't want system to adapt. It's not politically incorrect somehow to signal that you are, the system has to adapt and to adapt to a reference which is not good. So what is your opinion for ReadSpeaker?
I think it is important. There are some people in the Cobra project that are working on alignment and entrainment and that sort of thing. But I think it's important from the interlocutor's perspective, like how do you adapt to someone? Like you said, if you can't really change the accent while they're speaking, but you could say, oh, this person has trouble hearing or understanding, so I'm going to slow down my speaking rate, or I'm going to be more deliberate in emphasizing the words. That sort of thing I think is really important.
So we don't see so much research on this.
Not yet, maybe,
yet.
but it could come.
Yeah.
I think this whole area is probably going to develop over the next few years, and because I feel like already, since we can create such good synthesis, now there's room to explore more and to be more creative, hopefully.
To prepare the next session, we should wrap it up here. So
Oh,
let's thank Dr.
All right.
Klabbers again.
thank you.